Okay, now I'm gonna talk about the does work done depend upon the does kinetic energy depend upon the frame of reference? Kinetic energy depends upon the frame of reference. Upon frame of reference, and I would say that yes, again the answer is yes, just because for instance this is a truck or a car or any automobile. Two boys are standing here. The example same here, A, and this is a boy B standing here, and there's a boy standing on the road. For this boy, these two have kinetic energy, but according to this boy the kinetic energy of B is zero, just because this boy is at rest, right? So according to this boy both are in motion, but according to this boy is in rest. So that kinetic energy also depend upon the frame of reference, right? So now talk about conservative and non-conservative forces. If we talk about non-conservative forces, so it does depend upon the path. For instance, as we could say, let's talk about conservative forces first. So conservative forces does not depend upon force. So all the field later forces are conservative in nature. For instance, we could talk about gravitational force, nuclear force, and every field forces are conservative, and it does not depend upon the path. But one force, I would say that a frictional force, I guess, is conservative, non-conservative in nature, because it does depend upon the path. Now talking about the other thing in this work done important points that we're going to talk about, that the for instance we talk about cases of work done. For instance, this is a box placed on this surface. The force is applied on this box here, while the displacement take place here. So we would say that the direction of force and displacement is same. This because the work done is equals to F dot D cos 0, and cos 0 is equals to work, which means work done is force into displacement, which is a positive work done. And when the positive work done occurs, the body speeds up. Right? The speed of body increases, or a body speeds up when a positive work is done. While on the other hand, if we talk about here, the theta is equals to 0 degree. If a theta is equals to 90 degree, for instance, this is a box, displacement take place in this direction, but the normal reaction occurs in this direction, right? So force into displacement 90 degree. But we would not say that the work done on this body is exactly zero, just because when we talk about forces, we actually consider a frame of forces, or we relate it to one force. I'm only saying that the work done is zero when we talk about normal reaction to displacement, but gravitational field is also acting downward. Here the work done is not zero. If we talk about these two factors, then here the work done is not zero. So we would say that F is equals to work done is equals to I'm sorry, I might have mistaken. Normal reaction is a force, and into D. So here the work done is equals to 0, because angle between them is 90, and we could say that this is 0 work done. Here the speed of a body is 0. So we could write that the theta 0. Theta is greater than equal to 0 and less than equal to 90 degree. But if we talk about the third factor here, when we say that the theta is equals to 180, which means that this is a box. Frictional force acting in this direction, force is acting in this direction, displacement frictional force, and force is in the opposite direction, which means the 180 is equals to 0.